All right, students. So remember in the rock cycle when rocks are weathered? And so they're taken from big chunks to little tiny pieces. And weathering and soils go together because soil is 50% minerals, weathered rocks, just chunks of pieces of rock that are in the soil. So we're going to do our soils lesson, and just keep in mind that rock cycle diagram, and you could pull up the rock cycle PowerPoint and look at that again, because the weathering of rocks leads to formation of soil. Now, there is a difference between dirt and soil, okay? A lot of people say dirt thinking they can, use dirt to do this or dirt to do that. Dirt is 100% ground up rock. When a lot of people on campus use the same shortcut, and let's say they cut through the grass over and over and over, pretty soon there's no grass there. You've made a little path. That's dirt. Nothing can grow in dirt. Okay? Dirt is a totally different animal. Soil, on the other hand, is the interface between the living and the non-living world. It is such a vital part of our, food, culture. It's where, life actually, from energy from the sun, giving plants their, energy to make glucose, starting the food chain. Soil is so valuable and so important, and it's not dirt. And we'll see why, okay? So, soil is made up of different things. We have fantastic soil here in Michigan. That's why Detroit, with all the urban farms, is just such a great, wonderful thing that they're starting a lot of agricultural, little agricultural neighborhoods where they have their own little farm in the neighborhood growing fresh produce. We have fantastic soil. Whereas in the Amazon, the slash and burn, millions and millions of acres in the Amazon used up every single year because that soil is so nutrient poor. They just slash down the forest, they burn it, they can grow something for 1 or 2 years, and then they got to move on and slash down somewhere else. Our soil here is very rich, very great for growing. And Michigan's number 2 business is agriculture, and that's because we have such great soil. Okay, so your engage is to do the Earth as an apple, which is in the soils lesson. So you're going to take an apple and you're going to cut it as instructed, and you're going to answer those questions. So that's your engage for the soils lesson. Now your explore part is to look at different aspects of soil. And so we're going to just do a little bit of that here. So it says conduct the soil investigation with 3 different materials, sand, clay, and humus. And then we have our Michigan mix over here, which is nice Michigan soil. By the way, our soil is usually black soil, brown or black, very rich soil. In Georgia, if you dig, the soil's red. And that's because of the mineral content down there. That's because of the bedrock as well. Soil represents the bedrock that is underneath the ground that eventually makes its way to forming the soil. Okay, so let's look at your chart on your soils lesson. You have a chart, and so the first thing that it says that you're going to do is you're going to observe your sand with the hand lens. So you're going to have your little hand lens, you're going to have your sand sample. You're going to look at it, and you are going to write down your observations in the chart. So you're going to fill out this chart. So the first thing, observe with the hand lens. You observe, you write your observations. Observation is such an important part of science. Much of science comes from observation. Someone looks at the world, looks at something outside, looks at something in their space, and asks a question. And that is the importance of observation. Science, The more observations your students can do in your class, the better science-minded they will be. And believe me, we need people who have scientific minds in this world. All right, so you write your observations. I see flecks of different colors, different sizes. You write down whatever observation you make. Then you're going to touch it. You're going to touch it. You're going to write down what it feels like to you. What's interesting is some students will say it feels gritty, some students will say it feels soft, some students will say it feels sharp, dull. Can you tell a student, if a student says it feels soft to them, are you going to say, no, it doesn't feel soft. It should feel this way. No, we do not tell students what they are observing with their brain. Everyone's brain is a little different. When I was in school, teachers would be that mean and nasty and tell you what you were seeing, and even if you didn't think it was that way. But now, thank God, you guys, you'll let your students write their observations, what they see. Smelling it, you don't have to inhale the sand, okay? To smell things that might get in your nose, you can just hold it near and just waft it over. Some people say the sand smells like the beach. Some people say it smells musty, dirty, whatever. Whatever your observation is, you write that in your chart. Roll the wet sample. So you're going to get some water and you're going to get some sand. So I've got some water and my sand in my finger. And I'm going to try to roll it and write down what happens when you try to roll it. Let's do a little bit of rolling with the clay. Okay, I've got the clay. I got some water and the clay. And now I'm going to try to roll the clay. And lo and behold, can you see? The clay is like a little ball. Okay, so rolling the clay ended up with a little ball that I can roll around in my fingers. Rolling the sand, not so much. Okay, so you're going to roll the humus and the Michigan mix as well. I'm going to rinse off my fingers from that clay. Smear the wet sample. So smearing just means you're going to take the sample and you're going to just take it on some paper and smear it down and see if it leaves any tracks. You can see that clay left kind of like little gray tracks. Let me see if I can smear some hummus, get some hummus wet, and hummus leaves a little brown trail. Okay. So what you're going to do, oh, and the last thing before I move on is to shake it. Okay, so you're going to take a little bit of your sample, you're going to put it, you can make a little funnel out of a piece of paper, and you're going to shake it, and then you're going to let it settle. Okay, we're going to do the same to the humus. Whoops. Science is a little messy, so you gotta let your kids make a little mess sometimes in your classroom. Okay. Look at the humus when you shake the humus. What can you say about the density of humus? Another word for humus is peat. What can you say about the density of humus compared to the density of water? Okay, and watch this. Hopefully it'll work. Nope, it came out. Okay. Anyways, the humus is floating on the top. Okay. You're going to do the same with the Michigan mix, and you're going to do the same with the clay. You're going to shake them, let them settle. What you'll notice is as they settle, you'll notice like with this sand, there's still some material that's floating around. Eventually, that material will settle on top of the sand layer. Because the particles are so small, they take a while before they can sink down. You'll see all that happening. So what you're going to do is you're going to record all of your data in this data table. This is part of your soils online lesson. So you're going to do this lesson by yourself. This isn't a group lesson like the weathering of rocks one. This is a when you do it by yourself. Write all your observations and try to figure out what that local Michigan mixture is made out of. Do you see elements of the sand, the clay, the humus in there? Okay. And the next thing you're going to do is you're going to build a small compost bag. Okay? You're going to take some soil from outside your house. Just take a spoon out and dig up a little soil. Put it in a Ziploc bag. And then you're going to put some food scraps in there. Only use vegetable scraps and don't overwhelm the bag. Okay? So you're going to have a layer of soil, let's say like 1 inch deep at the bottom of the sandwich bag. Put in a few carrot peels or cucumber peels, maybe a couple of chunks of apple or something, and mix that up. Put 3 little holes in the Ziploc bag. You're making your own compost bag. Now, the great thing about compost, about plant, like corn on the cob peels, you know, peels from apples, peels from your different vegetables, the lettuce that's a little too rotten to put in the salad, all of that stuff is components of compost. Leaves. Okay? Within a few weeks, you will see the bacteria in the soil have changed all that plant matter into nice, rich soil. You can produce soil using compost within a matter of weeks. It takes the earth about 400 years to make 1 inch. It's about from this knuckle up, 1 inch of topsoil. It's about 400 years per inch. That is why our wonderful soil here in Michigan, we have at Michigan State University, which is our land grant college, we have soil conservation people that go to our farmers and teach them how to farm so that they don't lose their topsoil. Because when huge rains come, soil can be washed into rivers, and that soil that gets washed into rivers gets carried down by the river. And in fact, the Mississippi Delta from the Mississippi River is miles and miles and miles of soil that came from Minnesota and Iowa and other states the Mississippi River travels through and was deposited into the Gulf of Mexico, and in fact is, you know, New Orleans is inland because the delta keeps growing, because all this soil keeps getting carried down the river. So soil, we cannot say enough good things about our soil here in Michigan. We have great soil, we have great agriculture. You could go out right now and plant some kale seeds right now, and you could be eating kale from that garden till November, even December, because that will just grow in that nice rich soil. It's got a lot of nutrients. Excellent. Now, that's not the minerals aren't the only part of soil. In the beginning I said that soil is made up of minerals, and dirt is 100% minerals. But soil is typically 50% minerals. But what is the other part of soil? Why, when people walk over a path over and over that's growing grass, why eventually does nothing grow there? That's because soil also is 25% air. Okay, 25% air. When people stomp over a place over and over and over, eventually all that air is no longer. And roots need oxygen to grow. Roots need oxygen because they're not green and they're not getting the sunlight. They are doing respiration like us, so they're underground. They need oxygen. If they get no oxygen, they die, therefore the grass dies. And that's why that becomes, instead of soil, it just becomes plain old dirt where nothing will grow in it. So 50% minerals, 25% air, Soil, good soil is also about 20-25% water. So far, soil is minerals, air, and water. And there's one other component in good soil, and that would be organic matter, like this humus, which was once plant matter, was once a growing plant, and instead now is just organic matter. And this organic matter in the soil is a necessary part of the soil as well. When you make your compost bag, you're putting a lot of organic matter into that already good soil. Eventually the bacteria in the soil are going to also eat that. They eat whatever you put in there. And we get richer, better soil. So with soil, you're going to do this chart. And you're going to share your results on a large one in our lesson. But then you are also going to build your compost bag. And then you are going to talk about how the earth, or how soil is a good interface or a good depiction of our earth system. Our earth system consists of 4 spheres. The atmosphere, which is air, which is in soil. The hydrosphere, which is water, which is in soil. The geosphere, which is rocks, which is in soil. And the biosphere, which is that organic matter. So good soil contains all 4 of those components. So in the soils lesson, you're each going to turn in your own lesson, and you're going to answer that question. And the lesson has direct, tells you exactly where the points are. Filling in this is so many points, turning this is so many points. So go ahead and do that lesson on your own. Right, students, so remember we talked about soil as kind of an interface between the living and the non-living world. Through soil, we take sunlight and we make wonderful energy in plants. And the difference between dirt and soil right here. When you get the air and the water out of it, no organic matter, you've just got crushed rock. Remember, rocks are made of minerals. Minerals make up rocks. If you've got 100% mineral matter, you've just got dirt. Nothing's going to be happening in there. Now, I'm showing you this diagram because when you take your Michigan test for teacher certification, they're going to throw the kitchen sink at you. They would throw something like this at you. And they would say, tell me the components of sandy clay. And because you're developing a scientific mind, you're going to think, well, first of all, you're going to freak out because you've never seen anything like this before. But then you're going to say, okay, I can figure this out. And you can figure it out because you can see that there's colors. There's lines with colors. And you can see that the colors lead to words that are the same colors. So I'm just showing you this because I don't want you to freak out when you're taking your Michigan test for teacher certification and you get some crazy diagram like this thrown at you. I want you to be confident and know I can handle this. So let's look at the sandy clay. The green line to the green, 10% silt. The red line to the red, 40% clay, and the blue line to the blue, 50% sand. That's the mineral content of it. Clay loam. Loam is very good soil. That's kind of what we have here. 20% clay, 40% sand, 40% silt. All right? I just threw that at you because I don't want you to freak out when you're taking that test. All right, let's just look at a couple things I'm going to ask you on the exam. There's a difference between residual soil and transported soil. Residual soil comes from whatever that bedrock is in that area. So this unweathered bedrock here has a relationship to the soil on the top. And so it'll be a similar color. It'll be a similar makeup. This is just ground up minerals making their way to the top. Like I said before, in Georgia, they have red clay. They have red soil. The bedrock, the parent material has a lot of iron, a lot of red in it. Okay. Let's look at the other word, which was transported soil. The whole Mississippi Delta, which is such rich, beautiful soil that is just so full of nutrients and so great for growing things. That was all transported down the Mississippi River when it hits the Gulf of Mexico, because that water's flowing fast and all that soil is in the water, traveling with the water. It hits that slow Gulf of Mexico and just falls out. And that delta, it's like miles and miles of soil that came from farther up the river. That's transported soil. Has nothing to do with the bedrock down in Mississippi. Everything to do with the bedrock up in Minnesota and Iowa and other states where that traveled from. So that's the difference there in the transported soil. One more thing I want you to look at in soil, and that is the global soil regions. So when we look at the Amazon, when we look at this soil here, tropical forest soils, oxisols. This is so nutrient poor, the soil is horrible. That is why the Amazon is just continually being slashed and burned, because the people have to grow their food. They slash it, they burn it, that burning of it, get a little bit nutrient for the soil, but they can only grow for a couple years in that soil, and then it's depleted and they need to move on. Now, places like the Detroit Zoo are doing something about that, because they're employing, they have a butterfly farm down in South America where they're actually getting their cocoons for the butterfly house, and so they're providing a living for someone down there who does not have to go by the slash and burn. It's really, really, the Amazon is just going very quickly at this point. Look at us in Michigan. We have fabulous soil, the alpha soils, the high nutrient soils. That's why we can grow so much here in Michigan. Great soil.